3.2 has lots of stuff in it. So I wanted to kind of break it down over a few days so that we could really kind of analyze the pieces and parts. The thing that we want to focus on here, let's highlight a few things here. So the vertical intercept is the ordered pair corresponding to a value of 0 for the independent quantity, or the x. So really, it is just f of 0. So it's where x equals 0. So we're going to hit the y-axis. So you can call it the vertical intercept. Many times I'm going to call it the y-intercept. But all of those things, so they mean the same exact thing. Vertical intercept is the y-intercept. It's where x equals 0. So just remember, it's where you hit the y-axis. A function will only have one y-intercept because of the fact that if I plug in 0, I'm only ever going to get one thing. So you should expect only one of those. It may not be defined at 0, but if there is a y-intercept, it's only going to be one particular value. So let's take a look at number 4. It says a function h of x is defined by 39 minus 6.5x. It's representing the distance in meters that a tortoise is ahead of a hare in terms of the number of seconds since the start of a 100-meter race. So let's look at something for a moment here. Always write down what things stand for. So our x is the number of seconds. Our h of x is the meters that the tortoise is ahead. Okay. Now, it says to construct a graph of h. Now, hopefully you recognize that that is a linear function that we could put into the form y equals mx plus b. So if we put it into that form, let's put the x term first, and then let's put our b, our y-intercept. We can also, we could graph this, because it's a linear function, we can graph it as long as we have 2 points. So if we plug in 0, that is 39. Because of that 6.5 being that 6.5, let's multiply, let's use something even. Let's plug in 4. 2, 4, 6, anything even. If we plug in 4 into our function, negative 6.5 times 4 plus 39, we get 13. Okay? Okay, so it says to construct a graph of h. So let's go over to our graph paper. Let's put that our x is in seconds to remind us of that. Let's put that our h of x is in meters. Okay, so we have some information about what our axes are showing us. Take a look at your axes. We are counting by 1s along the x-axis, but we're counting by 5s along the y. So always account for what is showing up when it comes to that. So our first point we're going to put on the graph is at 0, 39. That was our y-intercept, our vertical intercept. Another point that we found, and you could have chosen a slightly different point, but I chose 413 as an option. And then let's go ahead and graph our line going through those points. So our graph looks like something like that. Now, positive values mean that the tortoise is ahead. So he starts out 39 meters ahead. And then there's going to become a spot right here where he gets behind, and the hare, he is, if he is 5 meters down, if he is 7 meters down, whatever the case may be, that means that the hare is in front of him. Okay. So that's kind of what those things mean. Now it says to use the graph to approximate the value of h at 4.5. So let's go ahead and do that, h of 4.5. So if you go over to the graph, find 4.5, and let's figure out what that point is. Can anybody share with me on your graph, on my graph? Now, your graph and my graph, we're guesstimating where those points are, so they should be close. Can anybody tell me what point you found at 4.5? Yes, 10. I think 10 is a good estimate. So that looks like 4.510. Now, what does that represent? Well, that means that at the 4.5 second mark, the tortoise is 10 meters, because it's positive, ahead of the hare. So that's what that means. Now, in part C, it says to use the algebraic representation of the function to evaluate h of 4.5. So what that means is we're going to take our 4.5 and find the exact value. So if we did 39 minus 6.5 times 4.5, we don't get 10, we get 9.75. Now, why did that happen? A graph, unless we are perfect machines like Desmos, a graph is a very close estimation of what is happening. So that's why our eyes can't detect much of a difference between 10 and 9.75. So maybe you thought it was 9.8, and another person thought it was 9.9, another person thought it was 10. I'm going to give that to you. But if you have an equation that matches it, the algebra should match it perfectly, and the graph should substantiate that. If you were to put this into Desmos, and you put that equation into Desmos, and you went to an x value of 4.5, it should verify what you're saying. So if you did the thing where you slid down to the point 4.5 onto the graph, it would say 9.75, even though it may look like 10. Okay. Everybody good with question number 4? Do we have any questions about what we got there? Okay. Now let's go ahead and talk about D. It says determine the vertical intercept of H. And what does it represent in the context? Well, that is h of 0. We found it earlier. That is our y-intercept. A vertical intercept is just your y-intercept. So that means at time 0, or at the start of the race, the tortoise has a 39-meter head start. That's all that means, okay? Or at time 0, the tortoise is at 39 meters ahead of the hare. So where we hit the x-axis and where we hit the y-axis can be very important pieces of information, because it gave us information in this case. Where did the tortoise start? He started at the 39-meter ahead mark. So that gives us some interesting information about how everything started. So your vertical intercept or your y-intercept is just your 0 value. If I plug in 0, what do I get? Or at the starting value for time, what do I get? Everybody okay with all of that? Okay. So now let's talk about horizontal intercepts. Horizontal intercepts are always going to be in the ordered pair of the form a comma 0. You'll notice that our y is equal to 0, or our function has been set equal to 0. It is where you hit the x-axis. It is our x-intercept. There's a few other names they give it. They sometimes will say zeros. They sometimes will say roots. So it is your responsibility to know if they ask for roots, set the function equal to 0. If they ask for zeros, set the function equal to 0. If they ask for your x-intercepts or horizontal intercepts, set the function equal to 0. So you have to know that language, and that is part of the algebra for calculus, pre-calculus sort of thing. Is you might have set functions equal to 0 last year, but you got to know the language of it, so that if I ask you to find the roots, you know what I mean. If I ask you to find the x-intercepts or y-intercepts, you know what I mean. So that's really kind of one thing you're going to notice here. The language of math is going to appear more, okay? So if we continue the same context from exercise 4, same equation. So let's kind of highlight that equation for us. Let's solve for where h of x equals 0. So h of x equals 0, you're going to write down your equation, 39 minus 6.5x. We're going to set it equal to 0. Now, there's a few different strategies to solve that. You can move the 6.5, you can move the 39. Doesn't matter. You decide. They're both going to get us in the same place. If you don't like negatives, move the 6.5. That would be 39 equals 6.5x. But it was okay to move the 39. There's nothing wrong with that. You decide. And then we're going to have to divide both sides by 6.5. So 39 divided by 6.5 is 6. So when they say, what is the root of h? The root of h is when x is equal to 6. That's a point. That is the point 6, 0. Now, what does that mean? That means at the 6-second mark, the distance between the tortoise and the hare is 0. Or the tortoise is ahead by 0 meters. It's an important piece of information. Now we know that at the 6-second mark that the hare has caught up with the tortoise. At the 6-second mark, the tortoise is ahead by 0 meters. The hare has caught him. So that's important. Now, on the bottom, number 6, that leads me to some of the iMath stuff. Do you see here where it says, answer by graphing the functions on your calculator? Desmos, Desmos, Desmos. Student earlier asked me, hey, I don't know how to find the maximum of this function. But there was a little thing right there on iMath that says use a graphing calculator. So you're going to want to throw this into Desmos and look at where the bumps are the highest for a maximum, where they're the lowest for a minimum. Okay, so let me show you what I mean. To determine the horizontal intercepts, remember that's just the x-intercepts. We're going to set the function equal to 0. So we're going to set that function equal to 0. And then you're just going to solve, okay? So let's go ahead and solve this. I would solve it first by simplifying the left side as much as possible. Let's distribute. We get that 4x minus 22 equals 0. So 4x equals 22. So x is 22 divided by 4, or 11 divided by 2, 5.5. Now, I will tell you that leaving 11 over 2 is a good bet. That's okay. But if you're looking on the graph, you should expect to see the point 5.5, 0. Okay, so if we put in the function, you can either write y equals 4 times the quantity of x minus 6 plus 2, or you can just type in what y is equal to. It'll assume that that's your y value. So type in your original equation, and then look where it hits the y-axis. Look at it. You might notice that we have hit it. Sorry. We've hit it at that 5.5 spot. It's exactly what the algebra should verify for us. Remember, your algebra and your graphical interpretation should align with one another, or one of those is wrong. Okay? Okay. So now let's do the second one, and I really like that the second one, the way that the second one is in factored form. Do you recognize that? That's that volume of the box by an 11 and 8.5 sheet of paper. If the 11 and the 8.5 changes, they're only going to change if your size of your paper changes. So if you have, say, like a sheet that's 5 by 9, you would have a 5 and a 9 instead of 11 and an 8.5. So note that that's going to change that. Okay. We're still going to rewrite the equation and set it equal to 0. Now, there's a great rule in algebra called the zero product property. If we have pieces that are multiplied together, we want to set them equal to 0. So we're going to get where x is equal to 0, 11 minus 2x equals 0, and 8.5 minus 2x equals 0. Any of the factors can equal 0 to make that thing equal to 0. So because we have 3 factors where that's happening, just pull them apart, you get 3 nice equations. And then we're just going to solve each one of those equations individually. So this one's done. We got an answer of 0. This one, we get that 11 equals 2x, so x is 11 halves. And then this one, we get 8.5 equals 2x. So x, they left a decimal, we'll use a decimal. That's 4.25. So now, when we put the original equation in, this equation, you'll notice, hits the vertical axis, the x-axis, I'm sorry, the horizontal axis, in 3 places. So it has 3 horizontal intercepts, 3 x-intercepts, 3 roots, 3 zeros, whatever you call it, it's all asking the same thing. It occurs at 0, 4.25, and then that 11 over 2 was 5.5. Okay. So please, your algebra, your graph, those things should always go together. Any questions about finding the zeros or the horizontal intercepts? Okay, then let's talk about the vertical line test. It says that any vertical line may only hit a function at most 1 point. So if we have a graphical interpretation of the function, so in number 7, we have this graph. And they say, is y a function of x? Y is a function of x it will pass the vertical line test. So if we can find even one vertical line that hits it more than once, we would say no. But here's a little new piece of information for you. The new piece of information is x a function of y. So this is actually going to be found using the horizontal line test. Will our horizontal lines only hit it in one spot? So think about once, 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 once. So in that case, that's a yes, it is. So if a vertical line hits it once, y is a function of x. The x's inputted will only ever give you one y. But this is actually a function of y. Every y value, every y value is only paired up once. And that's why horizontal lines will only ever touch it in one spot. Now, why is this important? Eventually, we'll talk about a function called a one-to-one function that passes both the vertical and the horizontal line test. It has to pair up exactly once in both directions. So that is something that is coming. So now, we're not done with this. We'll finish the last little piece about domain and range tomorrow. We'll talk a little bit about interval notation. So hold off on turning this in yet. We'll turn it in tomorrow most likely. And what I want you to do now for the remainder of class is I want you to go into iMath. Your iMath, you'll notice you have 3 homeworks due on Saturday. You should have already turned in the pre-courses for this week because you should have done them along with me. So those should be done. If they're not, you can open up those and finish those up. But your goal now is to work on the 3 homeworks that are due on Saturday. Start with homework M3-1 and then move on to M3-2 day 1 and then M3-2 day 2. That's what you need to work on now. And then it's a great time. If you have a friend in class you want to sit with and work on with, feel free to do that. If you want to bring up your iMath, if you're stuck on a particular one, come and see me. But iMath, do your iMath. Okay, so there you go.